This video looks at something called the discriminant. Now the discriminant is the b squared minus 4ac part of the quadratic equation. So remember, our quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is how we calculate the roots for any quadratic function in the format of the general equation ax squared plus bx plus c equals 0. And the discriminant, which is the bit underneath the square root sign, so the b squared minus 4ac, tells us the nature and how many roots a quadratic equation has. So if b squared minus 4ac is greater than 0, then there are two real and distinct roots. So you can see we've got two roots if we've got a positive x squared curve, and we've got two real and distinct roots if we've got a negative x squared curve. If b squared minus 4ac is a perfect square, the roots are rational. So in other words, if our answer is 4, 9, 16 and so on. And if b squared minus 4ac is not a perfect square, the roots are irrational. So in other words, if we have a surd or we've rounded it to 1 or 2 decimal places during our calculation. So for example, root 5, negative root 7 and so on. If b squared minus 4ac equals 0, then there is one real and equal root. So you can see for our positive x squared, it's a tangent to the x-axis, so it touches at one point. And for a negative x squared, we've got a maximum turning point that is a tangent to the x-axis, so it touches at one point. The third and final rule is if b squared minus 4ac is less than 0, and then there are no real roots. So as you can see, whether it's a positive x squared or a negative x squared, the maximum and minimum turning points don't cross the x-axis. Because remember, you can't square root a negative number, so you wouldn't be able to use a quadratic formula to find the roots. So we want to state the nature of the roots of 2x squared minus x plus 5. So the minute the question asks you about the nature, you're using the discriminant, and that's b squared minus 4ac. Now it's asking about roots, so we know in order to determine roots, we need to equate our 2x squared minus x plus 5 equals 0, and then compare it to our general equation ax squared plus bx plus c equals 0. And so we can determine that a equals 2, b equals negative 1, and c equals 5. And we're going to substitute these in to b squared minus 4ac, and we're going to get negative 1 squared minus 4 multiplied by 2 multiplied by 5. That gives us 1 take away 40, giving us a value of negative 39. And because b squared minus 4ac is less than 0, there are no real roots. So the minimum turning point of this curve would be above the x-axis. So in this example, we want to find the range of values of p such that 3x squared minus 6x plus p equals 0 has real and distinct roots. So for real and distinct roots, b squared minus 4ac has to be greater than 0. So we need to write down that condition, b squared minus 4ac is greater than 0. And then we need to compare our function to our general equation of a quadratic function, which is ax squared plus bx plus c equals 0. So a is going to equal 3, b is going to be negative 6, and c is going to be p. So we can substitute into our inequation and solve for p. So negative 6 squared minus 4 multiplied by 3 multiplied by p is going to be greater than 0. And negative 6 squared is 36, and we've got minus 12p greater than 0. So now we need to rearrange. So we're going to subtract 36 from both sides. That leaves us with negative 12p is greater than negative 36. Now we need to divide by the coefficient of p, and remember that if we are dividing by negative 12 on both sides, we need to flip our sign because we're dividing by a negative. And so we end up with p is less than 4. So therefore, the range of values of p such that 3x squared minus 6x plus p equals 0 has real and distinct roots is p has to be less than 4. If p is equal to 4, then it would have one real and equal root. And if p was greater than 4, then b squared minus 4ac would be less than 0, and so there would be no real roots. So for this condition, p has to be less than 4.